Okay, so this is video 2 for the hyperbolas. I just wrote these two pictures up here again just so we can keep referring to them so we know where the co-vertices are and vertices and foci are all located for each horizontal and vertical. Gentle reminder that when it's horizontal, the X is listed first. If it's vertical, the Y is listed first. So be careful you don't flip-flop those. So in the previous video, we were given an equation and we needed to graph it. This time we are given a graph and we want to write the equation. So first step is to identify, is it a horizontal or vertical? In this case, we have a horizontal parabola because it's facing to the left and to the right. We can also figure out what our center point is because it's going to be exactly in the middle of the vertices. So if this is a vertex in that one, we just draw a line. We need to find the middle of that. Since it's on a graph, and I'll zoom in so we can see it together, I'm just going to count it. If the full distance is 1, 2, 3, 4, 5, 6, I only have to go 3 in. So it's about right there is the middle. So that coordinate is going to be my center. So again, if this whole thing was 6, this is 3. And we've got, if this is 0, 1, 2, 3, 4, 5, negative 2 is our center. Okay, so we know it's going to be using this equation. So we're going to have x minus 5 squared y minus negative 2 or plus 2. But we don't know what our a and b are. So the a is the distance from the center to the vertice. So we've got that already. We know that from the center to the vertice is 3. So if a is 3, a squared is 9. There's that. Then we have to find the distance from the center to the co-vertice. It's going to be on the same line as the center. So this is what I was talking about when they put the little dotted box in the last video. So this coordinate looks like it's 1, 2, 3, 4, 5. What does it matter what the coordinate is? Why am I doing that? We just need to count the distance. What the heck is the distance from here to here? So we've got 1, 2, 3, 4, 5, 6, 7. B, the distance between the center and the co-vertice, is 7. So b squared is 49. I'll put 49 there. These are a little bit easier than the last video. Great. So that was 2a. I'm going to put in one for you to try. So for this one's a little bit easier just because our center is at 0, 0. So you don't need to really focus much on h and k. I'll post a clean copy of this on the next slide, so if you can't see it on the video, that's okay. So this was all about setting it up where if you were given a graph, can you write the equation? Notice that this one's going to be a vertical. So that was 2. This one is the set given a graph. Can you write the equation? Number 3 is given info. Yeah, we'll do that. So what do I mean by given info? It's kind of like, what if you were given pieces of the graph, but not the whole thing? So let's do what happens if they gave you the vertices and the co-vertices? All right, so we need to determine if it is vertical or horizontal. So let's look at the vertices. It's 4, 8, and 4, -8. The 4's didn't change, and that's the x spot. That means in both these coordinates, they have the same x value but different y, which means it's going to be vertical. So if we look at the picture, this vertex and this vertex have the same x value, but they have different y values. That's the same thing here. So this one's going to be vertical. We can find the center by finding the midpoint of the vertices. So again, with our picture, the center is right in the middle of the two vertices. So let's do midpoint formula. So midpoint formula between these 2 points, we'll do 4 plus 4 cut in half, 8 plus -8 cut in half. That will give us our center. 4 plus 4 cut in half, that would be 8 cut in half, which is 4. 8 plus -8 is 0, and 0 cut in half is just 0. So we found our center. Now, vertices and co-vertices are going to help us find our A value. So A is half the distance between these two vertices. So let's look at a picture and see what that means. The distance between here and here, if we cut it in half, that'll give us this piece that I'm darkening. So we're going to do the distance formula and then cut it in half. After we do the distance formula. So we're going to find the difference in the x's, 4 minus 4, 8 minus -8. Now 8 minus -8 is really plus 8. So this becomes the square root of 0 squared, 16 squared. Because of our deck principle, square root of 16 squared is just 16. And then we have 16 cut in half, which is 8. So if A equals 8, then A squared equals 64. Now our co-vertices is going to do the same thing, but with B. We'll have 1 take away 7 squared. 0 minus 0 squared is just going to be 0. 1 minus 7 is -6 squared. So -6 squared is 36. We have square root of 36 divided by 2, which is just 6 over 2, which is 3. So if B is 3, B squared is 9. So we've got our, our A squared and B squared, and we have our center. So that's enough information for us to draw or to write our equation. We know it's going to be in this format because it's a vertical hyperbola. So we're going to have y minus k, which is 0, over a squared, which is 64, minus x take away h, which is 4, over b squared, which is 9. There you go. We have it written. You don't have to do it as y minus 0. You could just do y squared if you want. Let's give you guys one. So let's call this 3a, 3b, is your guys' problem. If the vertices were 5, 0, and -5, 0, and covertices were 0, 2, and 0, -2. So I want you to write an equation for 3b. That one's good. Next one. All right, so let's figure out if it's vertical or horizontal. So in these ones, the y values didn't change, but the x values did. So if the y value is the same, the x's are differing. So that's going to be a horizontal. Now let's find the center by doing the midpoint formula. So we're going to do 12 plus -2 or -2 over 2, -6 plus -6 over 2. And then we'll get 10 over 2, which is 5, -12 over 2, which is -6. So there's our center of our hyperbola. Now let's figure out what our a and b are. Since it's horizontal, you know we're going to have this x minus 5, or h, over whatever a squared is, y minus -6, or plus 6, over whatever b squared is, equal to 1. So we need to figure out what a is. A is the distance between this point and this point cut in half. So we've got distance formula divided by 2. So we're going to do 12, take away -2 or plus 2, -6, take away -6 or plus 6. That's going to wind up being 0. Then we've got 14 squared underneath a radical, which is just going to be 14. We have 7. So if a equals 7, a squared equals 49. Then we'll do the same thing for b. We get 5 take away 5 squared, -12 minus 0. -12 squared is 144, and then the square root of 144 is 12 again. So we're going to get 12 over 2 equals 6. So if we have 6, b is 6, so b squared is 36. We have our a squared and b squared, so here goes 49 and here goes 36. And you're done. Let's do one for you to try, similar to that. This is 4b. Just a reminder, on Wednesday I'm going to post all the answers to my green practice problems. That one's for you to try. All right. Next one. Let's do 5A. Okay, so if you're ever given to with this plus or minus business, you almost have to like read it as 0, 3, and 0, -3. That's basically what this is saying. Same thing with this one. It's 0 positive square root of 73 and 0 negative square root of 73. Why is this one different than the ones that we've done before? Well, the ones that we've done before, we were able to find A and B. In this specific problem, we can find A and C, but we can't find B. We'd have to do that C equation to do so, which we'll see in a moment. So if this is vertices 0, 3, and 0, -3, then the x value isn't changing, but the y value is. So that's going to be a vertical hyperbola. We need to find our center. So what's the middle between 0, 3, and 0, -3? We could do that one in our head. Center is going to be 0, 0, which means, since it's vertical, we're going to do y minus 0 squared over whatever a squared is. Oops, not plus, minus. Minus x squared, whatever b is, equals 1. So we need to find a and b. A, this one's a little bit easier because we could do it in our head. What's the distance between 0 and one of these points? It's just 3 units. A squared is 9, so we've got 9 right here. And then we've got our C value. Distance between this positively and negatively is just going to be square root of 73. So C squared would be 73. Now we're going to do that equation. C squared is equal to A squared plus B squared. We just plug stuff in and solve for B. So 73 goes here, 9 goes there. I'm going to subtract both sides by 9 and get B squared equals 64. So we could keep going and say B equals 8, but we don't really need that, so I don't know why I did this. So this is B squared. We're just going to slap 64 right there, and then we'll be done. 5B. Five B for you guys is vertices and foci. Oops, foci. So you guys are going to have to do the distance formula to find the middles of those values, which will just follow the same steps that we did up here. Okay. I'm going to do a new page because I don't think I have enough room. This is not 6A. Let's do 5C, just because it's kind of similar to the other two that we did in 5. This one would be vertices right. So let's determine if it is horizontal or vertical. So looking at the vertices, the x didn't change, but the y did. So that's going to tell us that it's a vertical movement, or vertical hyperbola. We need to find our midpoint between these two. So we would do midpoint formula, 3 plus 3 over 2, negative 2 plus 10 over 2, and get 3, because that's 6 over 2. 8 over 2 is 4, so we would get 4. There's our center point. We can find our A. Ooh, I did this one wrong. It should be foci, not co-vertices. We've already done practice problems like that. So change that to foci. Sorry, guys. So we're going to be able to find our A and our C value from these. So to find A, we're going to do the distance formula and then cut it in half. So we will have 3 minus 3 squared plus negative 2 take away 10 squared. This is going to become 0. This is going to be negative 12 squared underneath a radical. So it's kind of like the square root of 144 and then divided by 2. 12 over 2 is 6. So if A is 6, A squared is 36. Now we're going to find our C value, which would be 3 take away 3 again, plus this statement, take away that. So this is going to be 4, I'll just write it all out, 4 plus 2 square root of 10 minus 4 minus 2 square root of 10. And all of that's being squared. Holy moly. Divided by 2. So let's simplify this before I do too much mental math. This is 0 plus 4 take away 4. Those cancel out. Oop, the 4. 2 take away negative 2 is negative 4. So we kind of have negative, oh wait, no. 4 take away negative is like adding. Right? Yeah. I misspoke. 2 take away negative 2 is like adding. So we really have positive 4 square root of 10. Square root of 10 doesn't change. Squared. And then bringing that divided by 2. Square root of anything squared is just itself. So this is going to become 4 square root of 10 over 2, which is like 2 square root of 10. If C is equal to this, then C squared is 2 square root of 10 squared. So C is equal to 2 squared is 4, square root of 10 squared is just 10. C squared is equal to 40. All right, we have our C squared and we have our A squared, but we need the B. So we're going to do 40 is equal to 36 plus B squared. That's the C squared equals A squared plus B squared equation that we keep using. Move 36 over, we have 4 equals B squared. We could keep solving, but we don't really need to because all we need is B squared. So we've got a vertical equation, so it's going to be y take away k, which is 4, over A squared, take away x minus h, which is 3, over B squared. And I'm done with that one. Okay, let's do 5D. So you could practice one similar to that. This one was pretty hard. 5C it was. So if you need help, message me and say like, I don't understand 5C. Can you give me a slower breakdown question? Or you have a specific question about a certain step? Screenshot it. Tell me what you need help with. Okay. This one is going to give us vertices and foci again. Vertices are 1, -9, and -7, -9. Foci are 2, -9, -8, -9. Cool. Okay, y'all. I have one more to do, and this video is done. So it's going to be 6A. What happens when they give you co-vertices and foci? We haven't done one like this yet. I didn't leave myself enough room to write these coordinates. Out of all the problems that I'm choosing for examples, the ones that I'm solving out are a lot harder than the ones that you're doing for practice. So if you see ones that I'm going over, you're like, what the heck, that looks impossible. Don't worry, you're not going to be given ones to work on by yourself that hard. So this one is a 51. Okay, so if the co-vertices are changing with a vertical change, that means the vertex or the vertices are having a horizontal change. So this one's going to have a horizontal parabola. And if you're not sure how I'm determining this, go back and study the pictures at the beginning of this video so you could determine how do parabolas, not parabolas, hyperbolas face. Okay, so if this is horizontal, we need to find the midpoint between these two. So I'm just doing the midpoint formula. We're going to do -2 plus -2 over 2, 0 plus 10 over 2, and get as our center. Okay, so we're going to be able to find our B and our C, but not our A. So let's find B first. B is the distance between these cut in half. So we're going to use the distance formula and then divide it by 2. -2 take away -2 is like +2. 0 take away 10. So this is kind of like square root of 0 plus 10 squared divided by 2. This is like the square root of 10 squared, which is just 10, then 10 cut in half, which is 5. So if B equals 5, B squared equals 25. Now let's do C. Okay. 2 plus square root of 51 minus 2 minus square root of 51. This is like, I don't know if I'm going to be able to squeeze it, but we can just verbalize it. 2 take away 2 is 0. Square root of 51 take away square root of 51. This becomes 2 square root of 51s. And then we have 5 take away 5, which is 0. So this whole thing winds up becoming this becomes 0. And then divided by 2. The square root of something squared is just itself. So we've got 2 square root of 51 over 2, or the square root of 51. If C is equal to that, then C squared is 51. So let's use our formula c squared equals a squared plus b squared to solve for a, because we don't know what a is. So I'm going to plug in 51 is equal to, I don't know, plus 25. And then we're going to solve. Minus 25 on both sides, and I get a squared equals 36. A equals 6. Oh, I don't know why I did that, because we don't really need to. We just needed that piece. Out of force of habit, I guess I just wanted to solve for a. It's horizontal, so it's going to be x first. X take away h, which is -2, so we're going to add 2 over a squared, which is 36, minus y take away k, minus 5, which was from our center, over b squared, which we found to be 25, equals 1. All right, and that's that one. The last one. This is the practice one for you. Do that. What happens if you're given covertices and foci? 5, -3. Okay. That's the end of the second video. These are long videos. Take a break if you need it.